Hey guys, the last section of the unit is called exponential functions, which means we are graphing again. So an exponential function is of the form like this: y equals a to the power of x. A has to be greater than 0, so it can't be negative and it can't be 0, and it also cannot be 1. So it's called an exponential function because your variable x is in the exponent. And these graphs have a specific form to them. There are 3 steps or things that we will go through for each problem, and there's, I can't number correctly, 6 problems that I will go through to help you with your assignment tonight. So we're going to be making a table. We also will be finding the y-intercept, and we've talked about the y-intercept before with lines. And remember, this means where does the graph cross the y-axis? To find the y-intercept, we substitute 0 in for x, and we solve the equation for y. We'll go through that together. And then this is a new topic, horizontal asymptote. This might be something difficult to grasp, but might make more sense once we actually do a problem. It tells us what the graph is doing as x gets really big or really small. So let me go through a problem with you. So a basic one is number 1, y equals 3 to the power of x. I have my graph set up in a table because table was step number 1. And so for x, we would like you to pick some easy values to work with that are positive and negative. So I'm going to pick -2, -1, 0, 1, and 2. So when I put -2 in for x, just to do my workout here, to show you what I'm doing, I get 3 to the power of -2. Now we've been working with negative exponents. Remember, that means that's 1 over 3 squared. And what's 3 squared? 9, so my answer is 1/9. When x is -1, that's 3 to the -1. That's 1 over 3 to the first, which is 1/3. 0, we've talked about this. 3 to the 0, anything to the 0 power is 1. 3 to the 1 is just 3, and then 3 squared is 9. So let's plot these. On the x-axis, I'm going to go by 1s, and on the y-axis, I have 1/9 all the way up to 9, so I'll probably just go by 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9. -2 is at 1/9. So you just have to kind of be approximate here. Say right there. -1 is at 1/3, which is a little bit bigger. 0 is at 1. 1 is at 3. And 2 is at 9. So when I teach this topic, students usually say, oh, it's kind of like a J-shaped. And it is in a way, except it doesn't curl up on the end. So exponential functions all have this curve to them. They're not a line. They have the same shape to them where they will go up like this, and then they come down, and in this case, they run along the x-axis. So they do not cross the x-axis, and it does not come back up. If you picked another point, like -3, -4, -5, you would see that these points get closer and closer and closer to the x-axis, but never touch it. If we were in the classroom together, we would be doing some exploration with the graphing calculator, but obviously that's not happening right now. So again, this is the shape. Sometimes the graph might be flipped the other way, and it could look like that, just so you know. But for these problems, you will always have that shape. If you get something else, you did something wrong. All right? And people always ask, should I always pick these x values? And for our purposes, yeah, keep your life easy. Choose -2, -1, 0, 1, and 2 for your x's. All right, so there's a graph, there's my table. I also asked you, what's your y-intercept? So y-intercept is where does it cross the y-axis when x is 0? Well, hey, we already did that work. It's at 0, 1. And then this other thing, this horizontal asymptote, I like to abbreviate as HA. So where is it what happens to the graph as x in this case is getting really small. So as x goes out and out and out and out to infinity, again, this would be something we would do on the graphing calculator, this graph, this part of the graph is going to get closer and closer and closer to the x-axis. And for those of you who remember, what is the equation of the x-axis? It is the line y equals 0. So that means as x gets really, really, really small, the y value is going to get closer and closer and closer to 0. I don't look over here because this is going up to infinity. It's getting really big. We're going to do more with this with every problem, so hang tight if that's confusing. All right, next one, stepping it up a little bit. Y equals 3 to the x minus 2. So I'm going to pick negative 2, negative 1, 0, 1, and 2. Okay. So you might notice that this is very similar to the other one. You have 3 to the x, but then you're subtracting 2. So again, I'd be putting negative 2 in for x, and so you're going to have 3 to the negative 2 minus 2. So that's going to be 1/9 minus 2. You are welcome to use a calculator for that, and that's going to be negative 1.8 repeating. Negative 1, that's 3 to the negative 1 minus 2, which is 1/3 minus 2. And again, you guys can use a calculator for that, that's okay. That's going to be negative 1.6 repeating. 0, 3 to the 0 minus 2, that's 1 minus 2, which is negative 1. 1 is going to give us 3 minus 2, which is 1. 2, 3 squared minus 2, that's 9 minus 2, which is 7. So this time my y values are going from almost negative 2 to 7. So 1, 2, 3, 4, 5, 6, 7. And there we go. Alright, so now I'm going to plot them. So negative 2 is at negative 1.8 repeating, so about right there. Negative 1, whoops, come on and focus, is at negative 1.6, so a little bit higher. 0 is at negative 1. 1 is at 1. And 2 is at 7. So again, this has this J shape to it. And before I actually graph this one, I'm going to jump down and explain the horizontal asymptote this time. So anytime, the trick here is anytime you have a number added or subtracted off the base there, that's your horizontal asymptote. So in this case, my horizontal asymptote is y equals negative 2. And it is this imaginary line, horizontal line, through negative 2, which means that this graph will come down and run along negative 2. So as this time, as x gets really, really, really small into negative world, this graph is going to get closer and closer and closer and closer to negative 2. My y-intercept, again, you already did the work for that. You're looking for when x is 0, what do you get? Negative 1. There's number 2. Number 3, this one's different. We have the x minus 2 in the exponent. I'm trying to do one of every type that you might see. So be careful with your algebra. We have negative 2 minus 2 in your exponent. So negative 2 minus 2, that's negative 4. 3 to the negative 4, that's 1 over 3 to the 4th. And 3 to the 4th is 81. That's a pretty small decimal, 1 over 81. Next we have 3 to the negative 1 minus 2. That's 3 to the negative 3, which is 1 over 3 cubed, which is 1 over 27. 3 to the 0, it's going to be, 0 minus 2, which is 3 to the negative 2, which is 1 over 3 squared, which is 1/9. These are all very small numbers. Next we have 3 to the power of 1 minus 2, which is 3 to the negative 1, which is 1 over 3. And then our last one, 3 to the 2 minus 2, that's 3 to the 0, which is 1. So if you need to go back through that arithmetic, rewind or pause it and look at what I did there. Okay, so our y values are going from 1 over 81 to 1. So it's pretty small. I might just go by a half this time, just to spread it out. And my x values are still the same. Now I'd like to point out here, you don't have anything added or subtracted to the power this time. So right now, you could answer me, what's the horizontal asymptote? Y equals 0. Technically there's a plus 0 on the end. The y-intercept, you could also answer that right now too. It's 0, 1/9. So let's graph it. -2 is at 1/81, which again is very, very close to 0. -1 is at 1/27th, which is a tiny bit bigger. Forgot what my scale was there for a minute. Whoops. Okay, 1/9 is a little bit bigger. 1 is at 1/3, so that's 0.3 repeating. So we're getting closer to 1/2. And then 2 is at 1. So again, you might look at this and be like, oh, this is a line. It's not a line. Remember, the horizontal asymptote, that's that imaginary line through y equals 0 that it will come down and run along to get that kind of curved J shape. Number 4, I'm giving you one with a fraction involved. Y equals 1/3 to the negative x. Okay, so we pick our numbers, and I'm going to have 1/3. It says to the negative x, so that's going to be -2, which is +2. How do we square a fraction? Well, what's 1/3 times 1/3? That's 1/9, or 0.1 repeating. -1, that's going to be -1, which is 1, which is just 1/3. 0 doesn't have a sign, so it's just 1/3 to the 0, which is 1. This is going to be a little tricky. This is going to be 1/3 to the -1. Now this depends how you did on the negative unit section a couple sections ago. When I have a fraction that's to a negative exponent, that means I flip it. So this becomes 3. You could also prove that to yourself by putting that in your calculator and saying 1/3 to the power of, I don't know if it would focus, -1, which is 3, for those of you using your calculator. This would be 1/3 to the -2. Because of the negative exponent, you have to flip it to 3 squared, which is 9. So we're going from 1/9 to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. -2 is at 1/9. -1 is at 1/3. 0 is at 1. 1 is at 3. And 2 is at 9. So again, you can answer the question of the horizontal asymptote because there's nothing added on to the end. It's just 0. So your horizontal asymptote is always of the form y equals whatever is added on to the end, which in this case is 0 because there's nothing there. Your y-intercept, like we've been talking about, is when x is 0, what's your y? In this case, we go to our table, it's 1. And so you make your nice J-shaped graph there. 2 more. I know this seems long, but it's nice to show you different ones, and I had problems numbering my work. Okay, and of course I forgot I had some on the back and I didn't pre-make my graphs. Oh well. Alright, so 2 more, here we go. Alright, so this one's a little bit different. We have a number added on to the end, and we have some stuff going on in the exponent. Oh man, I did it backwards because I'm talking and writing. Okay, so -2. So that's going to be 3. Now let's do a little bit of work in our head. -2 minus 1. That's going to be -3 plus 1. So 3 to the -3, that's 1/3 cubed. And then I have to add 1 to that. I'm running into the next problem. That's okay, we'll deal with that later. So that's 1/27 plus 1. You can use your calculator if you like a decimal approximation better, but that's going to be about 1.04, we'll say. -1. That's going to be, let's see, -1 minus 1 is -2. So that's 1/3 squared plus 1. which is 1/9 plus 1. You can use your calculator, and that's 1.1 repeating. 0, that's going to be 3. 0 minus 1, oh, I keep pointing to it, it's not on the camera. 0 minus 1 is -1 plus 1. 3 to the -1, that's 1 over 3. So 1/3 plus 1, that's 1.3 repeating. 1. 1 minus 1 is 0. 3 to the 0 is 1. 1 plus 1 is 2. 2 minus 1 is 1. 3 plus 1 is 4. So we'll set up the x's. The y's are going from 1 to 4. So there we go. We can answer our questions right now. Y-intercept is at 0, 1.3 repeating. And the horizontal asymptote is whatever is added on to the end. So it's y equals 1. So at y equals 1, it might help me to put in that dotted line, horizontal line, so I know not to go below that. So -2 is at 1.04. -1 is at 1.1 repeating. 0 is at 1.3 repeating. 1 is at 2. And 2 is at 4. So again, you got that nice exponential shape there. It's going to run along y equals 1. All right, and for my last one, I can take all the space I need here. Let's see. I'll make this x, y, and I'll do my graph down here. All right, so for this one, it's 2 times 3 to the x plus 1. 2, -1, 0, 1, and 2. So I know this is kind of a long video, but I'm going through a lot of different examples that you might see. So let's put -2 in. So we're going to have 2 times 3 to the what? Let's do a little bit of mental math. -2 plus 1 is -1. 3 to the -1 is 1/3. You can use your calculator if you need to, but 2 times 1/3 is 0.6 repeating. Next one, 2 times 3 to the -1 plus 1 is 0, and 3 to the 0 is 1, so 2 times 1 is 2. 0, 0 plus 1 is 1. So that means you're doing 2 times 3, which is 6. For 1, 1 plus 1 is 2. 3 squared is 9. 2 times 9 is 18. This is going to make for a larger graph here. 2 plus 1 is 3. 3 cubed is 27. And 27 times 2 is going to be 54. Okay, so down here, our x's can stay the same. Our y's are going from basically 0 all the way to 54. So I might go by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Remember, we've talked about changing your scale in class instead of just putting points and be like, oh yeah, it's up here. Change your scale. So -2 is at, actually, let's go back and answer our questions. So the y-intercept, 2 is being multiplied, not added or subtracted. There's nothing added or subtracted, so y equals, oh my gosh, I'm thinking of the horizontal, I'm sorry. My mind's all over the place. The horizontal asymptote is y equals 0 because nothing is added or subtracted onto the end. Remember, it's not about the exponent. The y-intercept, we look, well, when x is 0, what's y? We got 6 at our table. So let's plot our points and then we're done. -2 is at 0.6 repeating. So really far down there. -1, this thing would focus, hello, is at 2. -1 is at 2. So this is 5, remember. So right here. 0 is at 6. So a little bit there. 1 is at 18. So 10, 15, so this is 20. So 18 is about right there. And then 2 is at 54. So remember, our horizontal asymptote is at y equals 0, so that means we run along that line and we make the nice J shape, curve shape. Thanks for sticking with me through this. Bye.